So the official title of this talk is Up to the Attic, Math, Poetry, and Nostalgia. The attic part is, well, I went up to the attic this fall to go through my things, since I'm getting older. And also it's fun to go up to the attic and look through your old things. And I discovered a pile this high, several piles, they added up to that high, of writings, actual writings, poems, and so on, mostly rhyming, that I did in high school, but also math ideas. So my math story starts in 8th or 9th grade, I don't remember, when I first took algebra, and then I was instantly hooked on math. I was always, they told me I was good at math and so on, but I really, algebra explained a lot to me, why various math things worked. So I was passionate, I didn't use that word, but I had feelings, that's the word I used, feelings at the time. But I also wanted to mention that when I found these old creations that I did 50, 60 years ago, I immediately started writing more math poetry. I thought I had written it all, but no, more poetry about how I felt throughout my life about math, my passion for math. And so I wrote a whole series of poems, I called it Old Math. And it's about how I feel now, and I'll soon be reading some of those poems. It's about how I feel now about me then. Okay, so I wrote back to my adolescence, 15, 16 age. I wrote in my diary all the typical adolescent stuff, and also about my feelings about math. And I sort of came to poetry via math. Math was sort of my first poetry, and vice versa. But one of my claim to fame has been being a math poet, meaning writing about math. I'm not the only math poet. There's a community of math poets. So to give you an idea of me as an adolescent writing in my diary with all the adolescent feelings, including, for me, those about math, here's a poem that, well, I didn't call it a poem, but it appears in my first book of poetry under the title Diary Excerpt, Age 15. You know, falling in love is something like solving a polynomial equation. Everybody has his or her own polynomial, and the roots of that polynomial correspond to the loves that person has. Everyone has only a finite number of loves. Some people have polynomials with negative roots. That's when the loves live in different countries or died in childhood or something like that. Some people have polynomials with imaginary roots. That's when the loves are born on other planets or existed billions of years ago or billions of years from now or are amoebas or insects. And there are some people like me who have just plain linear polynomials. These people have just one love. So that was me at age around 15. And like I say, that was then, this is now. So all the other poems I'm reading are going to be poems that I wrote just this past fall. I've been interested in both the differences and the similarities between me then and me now. But I'll say also that math has gotten into my whole life. It's gotten into my teaching, my mothering. I've had 4 kids. Well, 4 are living, 1 is not. So it's gotten into my grieving. Life's challenges and joys, of which I've had many. And thrift shopping. Back to my collection called Old, in particular, or Old Math, it's called. So 2 things. First of all, yes, it's got actual math in it, but you don't have to understand the actual math to appreciate the poetry. And that's true of a lot of math poetry that other people write also. So part of the idea is that they contain math images, math poetic images, which can hopefully sound mysterious and poetic. So the first poem, it's the longest poem I'll be reading today. The other poems are not as long as this one. This poem is called Playing Euclid, and I was maybe 16 or so when I was doing all this stuff, but again, I wrote this poem very recently. I'd taken Geometry 1, then Geometry 2, then Solid, and I'd read Euclid. But, bless my high school heart, I wanted to start from scratch. I wanted my own geometry, my own elements, so I wrote my treatise. My treatise. Bless my partly imitative heart, I defined a line segment as the path of a moving point. And a full line is the path of two moving points which move in opposite directions from a particular point. I didn't say which point. I didn't know that I needed to prove the definition was independent of which point. But bless my sweet adolescent heart, I made a partly algebraic proof that only one straight line segment can be drawn from one point to another. There was actually a quadratic equation in there with solution n equals 1. Then I proved proposition 19. A circle cannot pass through 3 collinear points, and proposition 22. If the number of parallels through a point is constant, if it's independent of which point and which line, then that constant is 1. The idea was to prove Euclid's fifth from the first 4 postulates. I did know that's impossible, but I still wanted to give it a whirl. Now proving Euclid's fifth is equivalent to proving that the sum of the angles in a triangle is 180 degrees. Proposition 35 didn't get close at all. The sum of the angles in the triangle is less than 540. But proposition 39 got closer. The sum of those angles is less than 270. And proposition 45 was a little like calculus, which I didn't know at the time, and it got as close as we could desire and deserve. There was an infinite number of triangles, the sum of whose angles are 180 plus 10 over 3 to the nth power for any integer n, no matter how large. For the proof, I drew triangles inside triangles inside triangles, smaller and smaller triangles. Bless my child heart, it was my very own geometry. It was away from school, away from books, and away from Euclid, away from my slightly sadistic father and frustrated mother, and from all the boys in my classes who weren't asking me out. And the following is the shortest poem that you'll hear today from me. It's called Statement 2023. I feel tender toward my old math self, as tender as toward my baby and toddler self, as tender as though it weren't me. I don't believe in God. It's I who bless my heart. And another poem about where I was then. It's called More of My Very Own Geometry. This is just an excerpt of that poem. Proposition 33, the center of a circle is inside the circle. I liked thinking about insides and outsides. I read that you could think of insides and outsides as being interchanged. I saw a picture in a math book about an inside-out universe where a person's guts wandered around outside while planets and stars were crammed together inside. So bless my angsty heart. Maybe my guts were scattered in infinite space. And if I had a pain in one of them, a doctor couldn't fix it because it would be too far away. And this poem is also it's called Away from Euclid, more away from Euclid. Bless my innovative, naive heart. I worked on what I called crossing polygons. Who says the sides of a polygon can't cross? I proved that a crossing polygon can't be a triangle. The angle sum formulas for crossing polygons are different from 10 times n minus 2 times 180. A crossing polygon of only 4 sides has angle sum 720. And a crossing polygon of 7 sides can have angle sums only 180. There were inward and outward crossings. Outward crossings made the angle sum bigger. Inwards made it smaller. I loved the twists and turns. They seemed to indicate some kind of suffering. Bless my silly, trivial heart. I loved drawing those polygons. I drew far more than necessary. They were my very own polygons, no matter how silly, no matter how unimportant, no matter how few or no applications. However meager those mid-adolescent theorems and drawings, they were correct and true. And the following is kind of an important poem about where I stand now. And it's only the end of the poem. It's called My Very Own System, something I worked on when I was a kid. Okay. Old math felt romantic. Non-old math also feels romantic. My life in general has been romantic, including regular romance. But back then, way back then, I filled notebook after notebook with my old math. I plan to throw out most of those notebooks, not only because I don't want to burden my kids and grandkids with them, but because I don't need to burden me with them. What I'm writing now, instead, is better. It's a better approximation. Bless my adolescent and youthful heart, I made 60 years ago a good first approximation, and 50 years ago a good second approximation. Now, right now, third time's a charm. Here's more about how I feel now. It's called history. Writing this feels like writing a history of math. Well, math as I found it. I've taught history of math, and a student once said to me, I didn't know there was a history of math. Well, not math itself, I answered, but the history of humans learning about math. So this is a history of this particular human learning about math. I never liked taking history in school, but later I realized there can be a history of anything. History of childbirth, history of fashion, history of thrift shopping. Anything anybody loves has a history. So I like history now, in particular the history of my math. I do love my math. And here are two poems about career disappointments, coming to terms, and about my math style. Anticipation, it's called. Bless my self-centered, rationalizing heart. Maybe it's only the easy math that I love. Non-deep math, shallow math. A math professor I once knew said, some people are good at hard math, but not good at easy math. Well, bless my self-valuing heart, I'm good at easy math. Maybe someday I'll have a crack at hard math, like more category theory or Galois theory or Silo theorems. I'm big on the past, but I guess I have also a lot of math nostalgia for the future. Or maybe I'll just keep discovering more easy math. And this is called easy proofs. I used to call it definition hopping, any straightforward proof that depends only on the definitions and not on previous theorems or axioms. A lot of my proofs were definition hopping. That was okay with me. I'm okay with formulas that follow easily from the definitions. I like inventing a definition and then figuring out formulas about it. You have to really understand a definition in order to make up even easy formulas and proofs. No matter how easy something is, you still have to think about it, and you have to think of it in the first place. And the following is my next to last poem that I'm reading today. It's about the math that I'm doing now. But it goes back to ideas that I had back in high school. It's called Characterizing Associative Arithmetics, which is, associative arithmetics is an idea which I invented or thought of or discovered, whatever. That's been my lifelong goal, my pet math problem. It started in high school with my very own system. Bless my current heart. I'm now thinking about binary processes other than addition, which are associative and whose iterations are also associative. I've been trying to characterizing them, meaning describe all of them. In my paper, I proved a lot of things, and what I proved stands a good chance of getting published. But I didn't find all of them. I found only some. I proved they exist. No, I didn't solve the problem, and that's okay with a journal that might publish it. It's okay with me, too. I can also change the problem. I can change it to, are there associative arithmetics besides addition? And yes, there are. I didn't characterizing them, but bless my aging heart, I did find a lot of them. They're no longer lost. And my very last poem is called Selected Miscellaneous Theorems and Ideas, circa 1975. Theorem. Let K be a free totem with finite dimension, then any B set is a K basis, and therefore range K is well ordered. Theorem. Any compact set is a support of some distribution. Question, what are the K maximal sets when K is free? There I was, definition creator, definition hopper. There I was, theory creator, all the way. Problem solver, very little of the way. Bless my loyal math buff heart. There I was, and here I am. So I call it my attic odyssey, what I've been going through with math and with nostalgia. Helped me realize what I am and what I have been, and helped me be happy and satisfied with it. I was creative then, I'm creative now, and it's been fun and enough. Not everybody saves their old creations in any attic, and not everybody gets all excited about them, like I do. But for everybody, creative or not, math or not, the way we were is related to the way we are now. I once read an article. It asked whether we are the same person that we were when we were, say, children or younger. I believe, yes, we are. Or I feel that I certainly am. So even if the way we were isn't as good as the way we are, we can all learn from the way we once were. Thank you.